Okay, so we're doing Pythagorean theorem, which only works for what kind of angles? Do y'all know? Right angles. Do y'all know what a right angle is? What's a right angle? 90 degrees. So a 90-degree triangle has a 90-degree angle, and C is always the longest side. It's what's across from the 90-degree angle. Yes? A and B don't matter. You can flip-flop them. Yes? Okay, so knowing that, sides A and B are called the legs. Ew, my pen. And then they are shorter sides and form the right angle. Okay, side C is called the hypotenuse. Hypotenuse. Oh. I was about to spell that wrong. It is the longest side. And across from the right angle is a I don't know what that says. We're going to ignore that one. Okay, formula. Do y'all know what the formula is? Y'all don't know the Pythagorean theorem? Okay, so it's a squared plus b squared equals c squared. And this is like your picture showing why. You don't have to remember that. Okay, the Pythagorean theorem can be used to find missing side length of a right angle. So remember I said it has to be a right angle. Okay, to find the missing side length, substitute or plug in, substitute the given values into the formula and solve. And that's what we're about to do. So just so you know, usually A is the shortest side, but in the end, like I said, A and B don't matter. The only one that matters is C. So if we were just to label these, C is always diagonal from the right angle. Okay, and then we can say A and B. So again, C is always across from the right angle, A and B. So what would we call this one? A. This one? C, because it's across from my right angle. This one? B. What side is this? C. And then we can say A and B. That's an A, I promise. Everybody okay so far? Okay, cool. So finding a missing hypotenuse. Hypotenuse, remember, that's just your longest side. Okay, so we know our formula is a squared plus b squared equals c squared. And I'm going to label my side. So which side is C? X. This one's my C. So we could say A and B. And we're going to plug those values in. Now, I will tell you the best part about Pythagorean theorem is we don't really have to worry about negatives, because can you have a negative side length? No. So we don't really have to worry about parentheses, because that's when parentheses are super important. So what's the length of A? So we're going to say 3 squared plus what's the length of B? So 12 squared equals, and we don't know C, so I'm going to say C squared. We labeled it X, but I would just rather leave it C, because then whatever I get at the end is my answer. Okay. So from there, we're going to use our calculator. So I know the left side of my equal sign, because remember, we can type in this side. We can type this whole thing in. That's what we're going to type in our calculator. So we get 3 squared plus 12 squared. And we get 153. So I know that this side equals 153 equals c squared. Now here's my question. How do I get rid of a squared so I can find c? A square root. So I have to square root both sides to figure out what c equals. Remember, the square root cancels the squared, and we get c equals, bless you. We're going to do 150, the square root of 153. And it gives me an ugly decimal, which is fine. We're just going to round it to the nearest tenths place because that's what it says. Round to the nearest tenths if necessary. See that? Tenths place. So what's the tenths place? How many decimal places is that? How many zeros are in 10? 1. There's 1 0 in 10, right? So it's only one decimal place. So 12.3 or 12.4? 12.4 because that 6 makes us round up. So 12.4 is my answer, and we are labeled in inches, so this is inches. Okay, so looking at this one, again, we're just missing the hypotenuse. So same concept. I know that this side is C. We said usually our shorter side is A. So here's my 3 sides. And we know our formula is A squared plus B squared equals C squared. Now this one gives me decimals, which is fine. So A is 10.2 plus B is 34.5. So we're going to type that in our calculator. If I can reach my calculator. Oh, man. So 10.2 squared plus 34.5 squared. And I get this big old number. So I get 1,294.29 equals c squared. What's my last step? Square root. Square root cancels the squared, and I get c equals whatever that gives me. So square root 1294.29. And round it to the nearest tenths, what would that give me? 36. Because if I round 9 up, doesn't that just go to a whole number? So that's why it's 36. So 36, and this one's centimeters. Is this hard? No. You use your calculator. You just have to remember when you have something squared to find the answer, you just have to square root it. That's it. Most of this is in your calculator. So now the difference is if you look at the next ones, what are those missing? Is it my side C? No. So it says find a missing leg, which is a shorter side. It doesn't have to be the shortest side. It could be either side that's not the hypotenuse, okay? So knowing that, again, I know my formula is A squared plus B squared equals C squared. And which side is C? The 8.5. So we're going to label this one C. I'm just going to say A and B. Again, it doesn't matter. So if I know A, I don't know A, so I'm just going to rewrite A squared. What's B? So plus 6.5 squared equals what's C? 8.5 squared. So again, I just plug it in. What should we do next? So we can do one of two things. We can just say subtract and leave the squared, or we can simplify the squared. So let's go ahead and simplify the squareds just to make it a little less confusing. So 6.5 squared gives me 42. So we're going to rewrite this a squared plus 42.25 equals, if we do 8.5 squared, we get 72.25. And now we'll subtract. So we're going to do minus 42.25. And that gives me 30. Am I done? Is that my answer? No, why not? Yeah, I have that squared still, so I have to square root both sides. Square root cancels the squared, and I get a equals, so we'll type the square root of 30, and we round it to the nearest what? Yeah, 5.5 tenths. And that's centimeters. Okay, so let's look at this one. Same concept. So again, this is my side C. So we'll say A and B. So A is 4. We don't know B. And C is 7. What's 4 squared? 16. If you don't know that, is that okay? Yes, you can use your calculator. What's 7 squared? 49. Now what? Is it different because it's A versus B? No. How do I get rid of that 16? Subtract. So minus 16 minus 16. And I get B squared equals, I don't know what that is in my head. 49 minus 16, 33. What's my last step? Square root both sides. And I get B equals not 2. 5.7. Questions, comments, concerns? Is it that bad? No. Okay, so it says, write about it. Explain the difference between finding a hypotenuse and finding a missing leg. What was the difference between these? Huh? Yeah, when we did the longest side, when we found the hypotenuse, what did we just added, right? But when we found the leg, what did we subtracted? So, what can we say? When we do the hypotenuse, we add the squares. And then when we do the missing leg, we subtract the squares. We're going to skip these 3 because it's the same thing. Okay, and y'all are going to practice on your own in a second. So flip to the back. Okay, so using the Pythagorean theorem, we can find things in different ways. So if you look here, which one of these can we count? Which 2, I guess, to find the distance between the 2 dots? Well, aren't these straight across? So 1, 2, 3. So this is 3 units. However, can we count straight across to figure out exactly how many squares that is apart? No. It's diagonal. So we cannot count. Can we count this one? Yeah, how many is it? 2 units. So if it's horizontal or vertical, can we just count them and be done? However, when it's diagonal, can we do that? No, so what we're about to learn is explaining how we could figure this out using Pythagorean theorem. Huh? No, not quite. So we will use that to count. You'll see. Hold on. Okay, so filling in blanks here, it says to find the diagonal distance between 2 points on a coordinate plane, use the Pythagorean theorem. Pythagorean, bless you. Theorem. The diagonal distance between the 2 points is the hypotenuse, which is our side C. Okay, and the vertical and horizontal distance are the legs. Substitute the legs in for A and B and solve for C, which is the diagonal distance between the 2 points. So knowing that, let's look at this one. We'll come back to it. Okay, look in here. Okay, I'm going to just make a triangle. That's all we're doing. We're going to make a right triangle. So I'm going to do this and this. And didn't I just create a right triangle? And this is my C value, or my C side length. I don't know, hypotenuse. Okay, so knowing that, I'm going to count the boxes vertically. So 1, 2, 3, 4, 5. So this is 5. And then we're going to count them to the right. 1, 2, 3, 4, 5, 6. So this is 6. Can I use this information to find length C? Yeah, so it's just going to be, we can say this is A and this is B. So we'll say 5 squared plus 6 squared equals C squared. And this is where my calculator comes into play. 5 squared plus 6 squared is 61. And what's my last step? Square root both sides. So what does C equal? 7.8. We'll just say units. Pretty simple. Okay, so knowing that, I'm going to skip number 2. Let's look at number 3. Okay, so it says point J is located at -4, -3, 1, 2, 3. These are not the best graphs. Sorry, y'all. So this is point J. And point K is located at 5, 4. 5, 1, 2, 3, 4. Your ID badges make really good rulers. Or if you need a ruler, I have some. And we're trying to find that diagonal. So we will count our 2 sides. 1, 2, 3, 4, 5, 6, 7, I think. Did y'all get 7? My blind eyes struggle with these lines. 1, 2, 3, 4. And then 9. So we have 7 squared plus 9 squared equals c squared. So this is our c. We'll say a, b. So we get 130 equals c squared. Last step, square root both sides. Square root cancels my squared. And I get the square root of 130, which is 11.4. Pretty simple. Okay, I'm not going to do 2 more. We're just going to talk about 2 more. So if we look at 4, it says find the perimeter of the trapezoid. Well, if I find the perimeter, I can count this side length, which would be 1, 2, 3, 4, 5, 6, 7. I can find this side length, which is 5. Oops, sorry. And I can find this side length, which is also 5. But I don't know this one, do I? So what we could do is draw a vertical line. And that would make that a triangle, correct? And technically you could have drawn it this way. It doesn't matter. So it's a height of 5. And this would be 2. And then could we do 5 squared plus 2 squared equals c squared? Okay. Does that make sense? Okay. One more I want to talk about is this one. It says the distance between the park at Disney World is shown on the grid. If each unit represents half of a mile, what is the distance? Yada, yada. So could we just draw a triangle? We don't even need that one if we read it like I should have done. We just need these 2. So would we just draw down and over? Yes. Does that make sense? Make a right angle and you can figure it out no matter what. Cool? Awesome. Okay, one thing I want to talk about for tomorrow. Y'all don't have this paper, so you're just paying attention. If I tell you a TV has a width of 45 inches and a height of 30 inches, what is the length of the diagonal of the TV? Could we literally just label it? If I draw a TV, we want to know the diagonal. Do y'all know why we want to know the diagonal? Whenever they measure a TV, that's how many inches. Like if they tell you you have a 42-inch TV, it's the diagonal. Did y'all know that? It's not like straight across. Something like that. Anyways, computer screens, I don't know, different things. Anywho, I could be making that up, but you never know. Okay, so 45, 30, I know. I'm just showing you. So then would we squared not equals the diagonal? So tomorrow, is that pretty much the same thing? Yes. Another thing tomorrow is if I said, is this a right triangle? How would we figure that out? Yeah, could I plug these in and see if it's true? That's my right angle if this is a right triangle. Therefore, this is C, so I'd have A and B. So 7 squared plus 24 squared should equal 25 squared if this is a right triangle, right? So could we type it in and figure it out? So 7 squared plus 24 squared equals 625 equals, if I type 25 squared, is that also 625? So is this a right triangle? Yes. Does that make sense? Okay, now what if they were not equal? Then it's not a right triangle. That's all y'all are doing tomorrow. It's just proving right angles.